Good morning all. As a part of this program, today we will go for a factory visit where all the facade elements, various elements of the pertaining to facade, we will see the details of fabrication, assembly and making ready to send to the site for fixing. These facade elements we have today to cover main systems like unitized, semi-unitized and window. First we will see the production of unitized panels where various elements and various process we will show you, and we will show you a panel where what are the processes gone through and it is ready to dispatch. This if you see the panel cut, they are doing the cutting of the main members, namely the main members of this unitized panel assembly is mullion, where it will be always a vertical member, and there will be horizontal members called transom, and there will be adapters, and finally there will be a bonding. That is the most important process in this kind of work. You can see mullions, they are cutting for the required length. You can see two mullions kept together known as male mullion and female mullion. In the concept of unitized construction, the panels will go fully finished to site where it is produced by interlocking method. That is why we have male mullion and female mullion. Usually the male mullion will be on the left side and the female mullion on the right side. So, during the course of erection it will be just like tiling, where panels will be keep on mounting one after another, inserting into one another. They are seeing the required, they are doing the required cutting of the panel. Here, unlike windows, we require straight cuttings. Usually in window construction we will have all mitered 45-degree cutting. Here unlike that, in unitized and semi-unitized construction always the cutting will be straight. So, they are preparing the first panel. We will go through the process. All are requested to watch keenly. After cutting, the horizontal members will go for a milling. This is called end milling, where two blades used to cut out some of the portion so that it can be assembled with the vertical member easily. They are doing the necessary marking locations of the horizontal transom, where it is changing for project to project. In certain panels there will not be transom at all, where we will express the whole floor height as a single glass. But certain areas where we have vision panel and spandrel panel, there will be definitely a horizontal member. This member is known as transom, and we need to have marked the position and do the assembly. In unitized construction, usually it will be floor to floor. So, in a commercial building usually it will be 4 to 4.2 meter. So, always you can see the mullions will be around 4 meter plus. As I told you, a unitized panel assembly will consist of two mullions namely one female mullion, one male mullion. There will be number of horizontals, definitely there will be 2 horizontals at end, both ends. One will be the bottom, it is known as the sill transom, and one will be on top, it is known as the head transom. And according to the requirement of the project, either 1 or 2 intermediate transom will be there. Usually one of these particular compartment will be used for spandrel panel where vision is obstructed, namely inside there is a drop beam, we have to hide that by glass. So, there will be a preparation for spandrel panel also. They are doing the preparation to receive the transoms at exact locations. So, it is going to another process, we call it as copy routing, where the mullion and transom will be doing required cutouts, holes. If you see the unitized construction is kind of a drainage system, where all the water management doing through the system only. So, the external the area is known as wet chamber and the internal area is called as known as dry chamber. So, we need to do all kind of drainage arrangement from the wet chamber. If you see the system may absorb water from the atmosphere and it will drain out rather than resisting in the first primary barrier itself. So, all kind of drainages we have to organize through the system. For that drainage holes, slots will be made. In addition to that, the connection between transom and mullion we need to do the screw connections. For that also we will be doing necessary arrangements. The machine is known as copy router and it is very useful in the aluminum industry, facade industry. We know what kind of shape is to be done, that kind of shape slot will be kept on top and the router will move through that. So, it will be copied on the members either mullion or transom. If you see the detailing, the particular slotting they are doing on the wet chamber means wet portion, external portion of the system. If you see the pair of mullions there, middle portion is a portion is cut out for around 2 meter length, that is to receive openable panel. This particular panel is at vision area there is an openable panel also. Every panel may not have openable panels because as per the building norms we may have to provide 5% of the openable panels. So, every 10 panel 1 or 2 panel there will be openable panels. This particular panel is having a openable at the middle portion. Now, they are preparing for the assembly. Male mullion is here, the other side you can see the female mullion. They are making cutouts to assemble to facilitate the assembly. When we talk about a unitized system, we have various systems in place to facilitate various grid size to facilitate various floor heights, but essentially for every system there will be a pair of mullions and number of transoms and glass, and here all this process involved the assembly plus finally it is go through a process called bonding, that in the due course we are showing that is the most important in this process. These are all screw hole preparations. It is they are preparing little slanted because when we tight it will come closer and closer. Now one most important aspect what they are doing is when we are doing the assembly, mullion and transom they are touching each other at the same time, that should be airproof and waterproof. So the face where they are touching each other will be sealed with structural silicon. So after assembly it will be intact, there will not be any air infiltration and water infiltration. Now they are going for the assembly. From the assembly you can see essentially there is a sill transom, there is a head transom and two intermediate transoms, which one will be for the spandrel panel and the bigger area for the openable panel. So we can say this panel have a vision panel, an openable panel and a spandrel panel. As I told you earlier, there will be head transom and sill transom at the edges, it will be always half, but intermediate transoms will be full because it no need to receive any other panel. So now they are connecting two intermediate transoms which facilitate spandrel panel and openable panel. The particular dimensions and thickness, everything will be designed by the structural requirements. The main criteria for the decision making is the floor to floor height and the grid at what kind of lines we are planning, maybe at 4 feet or 5 feet, 6 feet we have to express the glass. If you want to express a big glass, we may go up to 6 feet, where every 6 feet there will be a vertical mullions. So that particular data plus the prevailing wind load of that particular area as per the IS code. Wind code will give you the necessary wind load is to be taken for design criteria, and we have to design around 20-30% safety factor. So this major three criteria for the decision or design of the particular cross section measurements, where more deeper will give you more section modulus and more thickness will give you more strength. So this system will be selected according to this requirement of floor to floor height, prevailing wind load as per the wind code, and what kind of grid we want to provide. You can see once again that recessed portion is for to receive the openable panel. Usually openable panel will be provided at 1.2 meter from the floor level, so that it is safe to operate and there is no safety threat. And what they are inserting are the gaskets. It play a major role in the facade industry, where glass we cannot directly touch or mount on the metals where breakage will be a major problem. So, every contact between glass and aluminum is avoided by providing necessary gaskets, and these gaskets play a very important role in avoiding leakages and air infiltration. So, when we press the glass unit against the aluminum system, it will give you pressure which will eliminate this water leakage and air leakage. And suppose you want to keep the ambience pressure inside and outside same, we call it as pressure equalization. So, necessary hidden holes are given in the system towards outside and inside, which is not in one line, which is staggered, so that water will not leak. So, there will be air passage in small quantity. So, whenever there is a pressure drop inside, air will be sucked automatically through these small holes to keep the pressure equal on both sides, inside and outside. So, they joined already one mid transom. They are making necessary fasteners in the system. If you see properly, that position is also well defined. So, when you call it as a system, the transom will give you screw ports, or the locations of the screws are all decided earlier. It is in the extrusion itself, there is no uncertainty in that. Now, they are going to assemble the second intermediate transom. You see a necessary special shape is already drawn on the transom, so that when it sit itself, it will very easy to assemble, and that screws going in the exact location where there will be a receiver on the transom itself. These are all taken care in the design itself. They have done the screw holes in exact locations where transom will come, and transom will come with its own screw locations where it will, there is a receiver within that transom, there will be a receiver. Now, they are doing the second intermediate transom. Now, finally coming to the last one. Now, after assembly, we call it as a naked panel, where all the assembly is done, gaskets are inserted, and you can see chambers 1, 2, 3. This is ready to receive glasses, and you see that space is provided to receive the glasses to glue it. Actually, the entire process is called structural glazing, where there is no mechanical fastening between the glass and the system. You see that space is already created, where glass will be in contact with the system for a particular space, that is also well defined. That space is also well defined. We call it as silicon bight. So, what is a silicon bight? It is the necessary contact width between the glass and the system. When you see from the top, in the top view, it is the width of the contact between the glass and the aluminum members, namely mullion and transom, that will impart strength to the glass for holding it in its position. And the thickness of the bonding is called glue line, that is also from the manufacturer there is a specification. In ideal conditions it should be around 5 to 8 millimeter, usually we will use 6 millimeter. This will facilitate the application where the silicon bite width of the contact is as per the design it should be around 10 to 15 millimeter all around, and the thickness of the application usually it is 6 millimeter, so that the silicon gun application is feasible. Now they are doing the openable panel assembly separately, where its all members are crimped and it is ready to receive. It will be fixed mechanically within the system in the middle portion where it is prepared already, and here also there will be a glass bonding. That process is called structural bonding. Every panel may not have the openable panel, usually I told you it will be around 5% to 10%. So every 10th panel or every 20th panel there will be a openable panel. This is for, if it is an AC building, this is for fire norms. When there is a fire smoke we can keep panel open so that smoke can escape, we can get the fresh air. Or in the winter we can keep the openable panel in open condition so that ambience cold air can come in, so you can save the AC energy. So in totality a unitized panel assembly require mullions female and male, transoms, sill transom and head transom, and intermediate transoms as per the design requirement, and all kind of gaskets, and we have openable panel, and finally we have glass for all this, and behind where we do not want to express that glass as a vision panel, there will be a spandrel preparation. Spandrel is nothing but a preparation of 2-inch thick chamber having rock wool in it or glass wool in it to enhance the thermal energy requirements, so that the conduction of energy, the transfer of energy will be as less as possible. Usually spandrel will be provided where there will be a drop beam and you do not want to express as a drop beam in the from the external elevation. So when you feel it from the external elevation, it will be a continuous glass facade, but in that particular, behind that particular glass there will be a drop beam. So that will support, give us chance for fixing also. Now this particular panel is coming for bonding or any other panel is coming for bonding. This is a bonding chamber where structural silicon is used as the bonding material. Many people call it as glue, actually it is a structural silicon where it is a two-part system where a main body will be in that blue chamber, the other one will be in the white chamber. That white chamber is nothing but a catalyst where it will be around 10% of the main body, and it will be kept separately. When it is coming for application, the particular nozzle it will mix together, and before coming for the actual gun application it will become a very homogeneous material, and it start like concrete, it will start setting, and within 1 hour it will give you strength to handle the panels, and within 24 hours it will attain its total strength. So instead of that unitized panel bonding, now they have taken a semi unitized panel, small semi unitized panel where we call it as glass frame assembly. You can see a glass frame, it is ready to receive the glass for bonding. This is a maybe 1 meter by 1.5 meter glass which will be used in semi unitized construction, where a glass frame is done. A space is created already where they are applying a tape, it is called Norton tape. It is a self adhesive tape. The purpose of the tape is, initially before applying the structural silicon, it has to hold the glass in position. At the same time, this particular tape width and thickness will decide the size of the bonding. Contact, the bonding size of the bonding nothing but the contact between the glass and the aluminum frame. here a space of around 25 millimeter was there, in that they are applying a tape of 10 millimeter wide. So, a balance space of 15 millimeter is created for the bonding, and that tape thickness is 6 millimeter. So, the frame will hold the glass 6 millimeter away, so that a space is created for application of structural sealant through the 6 millimeter. So, in this particular case, when we do the bonding, there will be a silicon bite of around 15 millimeter, and there will be a glue line. We thickness is known as glue line. There is a glue line of 6 millimeter. So, this self adhesive tape, double sided tape, play a very important role in the bonding, where while bonding the like concrete, it is a very weak material, it cannot hold the glass in position, or we cannot ensure the uniformity of thickness of application. For this tape will ensure the thickness of the application plus balance space will be created for the silicon bite. Here you can see they are doing the cleaning, necessary cleaning is to be done, thorough cleaning is to be done like any other concrete activity. It is almost like a concreting activity, where we have to clean the foam work and entire area where concrete is coming in contact. Now they are applying very mild soap application to have a complete cleaning of the surface of the glass which is going to be in contact with the frame, and they have to apply certain primer for enhancing the adhesion, and always they apply in double layer, so that little bit left out will be covered by the second application. Now a frame is prepared fully, now the glass is under preparation. You see the way they are applying the primer at the edges around 1 inch, where glass will be in contact with the frame. So, a semi unitized glass frame with the necessary tapes created, space for the bonding, then this will be attached to the glass. The primary bonding is nothing but the double sided tape. This is nothing but a primer application on the frame also. You see the outside space is created, 15 millimeter by thickness of the tape around 6 millimeter, space is created for bonding. Now glass will be placed on top of that. Both panels are prepared now with the necessary primer application. Primer requirement is depending on the surface of the aluminum. For powder coating there is a primer, and there is if it is anodized finish, there is another primer. In both cases we have to apply the primer, so that it will facilitate the bonding better. This is the bonding machine. As I told you earlier, it is a 2-part silicon bonding machine, where both the parts are kept there. That big drum is carrying the body, and the white small drum is carrying the catalyst. Body will be white in color, catalyst will be black in color. In the gun always it will be white, and while application it is mixing through the nozzle only. Now the light showing red means it is not properly mixed, and you can see uniformity is not there. Now the sensor showing green means the entire material coming through is thoroughly mixed as per the ratio. Usually we will keep 10% of the catalyst, and you can see a uniform black color, and we will not start the bonding like that. We will have 2 tests before starting of every bonding activity, because this is a very important, it is nothing other than like a concreting, very important activity. They will do a butterfly test, where this particular uniform homogeneous mix will be applied on a paper. It is applied, and thoroughly they will squeeze it. They will squeeze it to a very thin thickness, and they will open it. They will watch whether it is giving a very uniform color black. If any white patches or white dots means the mixing is not proper, then they have to again remove the material and they have to see the mix once again. And now they are doing the snap test. It is like a cube test. It is like a cube test in concreting, where snap test is done. They will keep a rod in that, and within 5 minutes it has to carry its own load, and within 1 hour it should be giving a reasonable strength. So, that is the second test before bonding. Now, they can start the bonding. Again they are applying a final primer. You can see the space is already created between the frame and the glass. Through that 6 millimeter they are applying the mix. It will go in pressure and it will occupy the entire space. So, almost 15 millimeter in width and 6 millimeter in depth silicon will be applied, structural silicon will be applied. See, it is by pressure it is going inside all 4 sides. Now, they are removing the surplus. While this process, certain space inside balance also it will be filled. So, the way they are wiping out, it will go inside and whatever inside void also will be filled. Whatever voids inside is a inferior quality. We cannot leave the space inside, then bonding strength will be less. Even though you are usually keeping 30-40% of factor of safety here, suppose a silicon bite of 10 mm required, we will doing around 14-15 millimeter silicon bite, because to give allowance for the manual errors. Now, the full bonding is done, surplus is removed. We can leave this panel for 1 hour for curing. Now, we are coming back to the earlier panel or another panel unitized, where a single glass unitized panel. You can see a single floor to floor unitized panel around 4.2 meter, male mullion, female mullion, head transom, sill transom. A space is created. This is for full glass. You can see the offsets on all around, that is the space created for the bonding. Now, they are applying masking tape to protect the aluminum from the surplus spillover. It is not for any other purpose. Masking tape is done wherever we do not want to spill the silicon, later it will be very difficult to clean. So, they are protecting the aluminum first. There is a protection tape already, but they are doing one more masking tape to, this is the best way to protect. Now, they are applying Norton tape, it is very important, double sided tape they are applying to ensure two things. One is the thickness of the application, they are ensuring by this. What is the thickness of application? Thickness of application is nothing but the thickness of the tape. It is a 6 millimeter tape they are applying, and they place the glass on top of that. So, already a void space is created of 6 millimeter. You see, they will apply all around. I think there is a mid transom also. I told you earlier it is top transom and sill and head. Now, there is a mid transom also. There is a small space for spandrel panel. Now, all the periphery they are applying the double sided tape. The purpose is to decide the application thickness. Indirectly, it will decide the width of the application also, where silicon will be in contact with the frame. It is a big glass, they are removing the protection tape from the glass first to facilitate the proper adhesion. Proper cleaning is to be done. It is a double glazed unit DGU, where surplus earlier silicon application and all we have to remove. They have to have a thorough cleaning on top of this. Thorough cleaning of the periphery. This is a particular panel without openable panel. So, we have a vision panel of around 3 meter and a spandrel panel of around 0.6. So, this is a single panel having a big glass and a small spandrel panel. They have to look for the edges where glass in contact with the aluminum member, bonding is happening there. So, now they are going for the cleaning and the primer application. They have to clean the edge of the double glazed unit also, because this edge also going to be in contact with the structural silicon. Now, they have to apply the primer on the other side. They are using the vacuum catches to hold the glasses. You see the double sided tape with coming with a tape on top of that they will remove on due course. Now, they are checking whether correctness. We have to leave 6 millimeter all around uniformly, a space 6 milli all around they have to leave as per the system. This will facilitate for application, gun application of the silicon. Now, they will make sure that all around we are getting the same space. That blue is a protection tape from the double sided tape, that is to be removed first, then only proper adhesion will be there. Now, panel is getting ready with the primary adhesion of double sided tape. You can see the periphery, that black border, it is nothing but space created for the bonding. Now, this panel is fully ready for bonding. You see black border on all around, it is ready to receive the silicon. Now, they are applying masking tape on top of the glass to avoid spillover, so that you will see a sharp groove line. If you see this panel from top, they are applying is a primary bonding only, but they have to do the real application from the back side. They have to reverse the panel and they have to do the application for the silicon, actually silicon bite. This space they are doing, this application is to avoid breaking of the glass due to expansion. So, it is within a confined frame. When glass expands, it will go and touch the metal frame. To avoid that, we bring glass 6 millimeter short, and all around there will be a silicon application. That silicon is flexible, it can expand or contract up to 50% of its width. So, when we do a 6 millimeter silicon there, it can go plus or minus 3 millimeter. So, thermal expansion up to 3 millimeter is protected. It will give space for glass to expand or contract without leaving from it. And the actual application of structural silicon is on the bottom, where space is already created, that I will show you on due course.